Keystone Engineering College, and I am here to explain you on the topic fault clearing process. In the substation, there are the various type of faults which present due to short circuit, open circuit, and there are number of faults such like symmetrical fault and unsymmetrical fault, which are present in the circuit due to the over voltage and the over current. So we have to remove these all type of faults to protect the equipment. If we not remove this fault, they will damage our equipment. So first of all, we have to understand what is a fault removing process. Whenever the fault occurs, the current is abruptly increases in the circuit. In the circuit, there is each and every equipment has their certain current rating. If the current rating increases beyond their capacity, it is called the fault. That means if the current flows beyond the rated capacity or beyond the excessive permissible limit, it is called the faulty current. And the faulty current is generated due to various type of fault such like symmetrical, unsymmetrical, under voltage, over voltage, under frequency and over frequency. These are the certain type of fault which has to be removed to protect the equipment. So first of all, in the earlier days we are using the fuse. Fuse is a basically purpose which works on the melting point. There is a wire which melt when the heat entered in the circuit. After that, as the rating of the equipment increases, as the voltage rating increases, the fuse are not very much reliable. So after that, we are using the relays and the circuit breaker. But the relay is not a protection device which is used as a protection device with the help of circuit breaker. Basically, relay is a sensing device which is used to sense the fault whenever the fault occurs. The fault occurs when the current exceeds their certain limit. So relay will sense this excessive current and send the command to circuit breaker to open its contact. So we have to understand with the simple diagram. This is a basic diagram of how the fault is being removed from this circuit. This is a battery source, relay operating coil, CT. This is the primary of CT and this is the secondary of CT. This is circuit breaker, bus bar and a coil which should be tripped whenever the fault occurs. But when the normal operating condition, there is a current flow in the CT, primary winding. This is called the normal operating current. But whenever the fault occurs due to the certain reason, what happened? The current flow through the secondary of CT. This is the basic phenomena. Whenever the fault occurs, the current flow through the secondary of the CT. Whenever the normal operating condition, the current I1 is equal to I2. But there is this is not a comparison element where the CT current is fixed. It will be checked that what is the value of CT current and what is the value of occurring current. This is the ratio of actual current and there is a ratio of change in the current. If there is any change, that means the excessive current will flow through the secondary of CT. And this CT is known as relay operating coil. In this case, the relay will close its contact and it sends the command to the circuit breaker to open its contact. From this way, it will send the command to the circuit breaker to open its contact, and this fault is protected, or this excessive current is protected from bus bar, and this bus bar is protected from the excessive current. This is the basic phenomena how the fault is removed from the circuit, and all this function is done by this battery source. This is a battery source which provides the supply to the relay operating coil, and now it will be send the command to the circuit breaker. This is a basic phenomena that relay will close its contact and the circuit breaker will open its contact. Now we are taking the example of the generator protection, that how the generator is protected from the fault. This is the basic diagram how the generator is being protected from the fault. First of all, we have to understand that what kind of equipment we are using in this circuit. This is a generator CT1. This is called the primary side of current transformer. This is the secondary side of current transformer. There are the circuit breaker installed, and there is a balancing resistance. And this is for the relay operating coil. First of all, we have to understand what is fault. There are the various type of faults which are being occurs whenever due to the pole voltage, due to the pole current. There are mainly two type of fault: symmetrical fault or unsymmetrical fault. These are the three-phase fault, line-to-line fault, line-to-ground fault. There are the various type of fault present in the nature. That's why the current rating of the equipment will increases. So we have to protect this generator from this excessive current. Second, we are using the relay. What is the relay? Relay is a basically sensing device which is used to sense the fault whenever there is a current change. Basically, this type of relay which is used to sense the incoming fault and which is used to find out the incoming current and outgoing current. This is basically compare what is the current enter in the CT and what is the current outgoing from the CT. Basically, it is called the comparison relay, which is used to compare the incoming current and outgoing current. But in the normal operation condition, this incoming current and outgoing current is equal. Second, there are the many circuit breaker. There are the many types of circuit breaker which can be used, like air circuit breaker, oil circuit breaker, air blast circuit breaker, vacuum circuit breaker, and SF6 circuit breaker. As much, we can also use the various type of relays in the nature. There are basically three type of relay which can be used. They are basically three type of relay, which is also known as direction relay, differential relay. But in this case, we are using the Merz price separating current principle. In this current, the incoming current and outgoing current are being compared. Okay, this is called the circuit breaker, which wait for the command which comes from the relay. Relay will sense the fault and it sends the command to the circuit breaker to open its contact. But in the normal operating condition, when the incoming current and outgoing current is equal, the relay will not operate. Relay will operate only when there is a change in the current. It is called the Merz price separating current principle. Okay. In this case, there is a transmission line R by B where the current should be flow, and in the normal condition, the rating of incoming current is I1 and outgoing current is I2. But whenever the fault occurs, the I1 is not equal to I2. That means the excessive current will flow through the relay operating coil with the help of pilot wire. We are using the pilot wire here, which is used to carry this excessive current. The pilot wire which can carry the high amount of current, and this high amount of current will flow through the relay operating coil. There is a balancing resistor also used to neutralize the effect of the current to the relay coil and the circuit breaker. But we have to protect the relay also. If there is no protection provided for the relay, then relay can also be damaged. So we are providing the balancing resistance. And this excessive current will sense by the relay operating coil, and this circuit should be tripped. And this circuit should be tripped. That means relay will close its contact and send the command to the circuit breaker, which open its contact. And this generator is being protected from this excessive current. This phenomena is completely, we can understand by this fault clearing process. This is a basic phenomena, and this is the actual how the relay will operate. Okay? Now thank you.